Hi students, welcome to our physics class now. In this class we are going to learn applications of dimensional formula. It is a part 2 video. Already we did part 1 video. In this video, so we can learn the conversion of units of physical quantity from one system into another system. So using a dimensional formula or dimensional analysis. So how can we convert the unit of given physical quantity from CGS system into SI system or SI system into CGS system? So for this one, we follow the principle of homogeneity. So from the principle of homogeneity, we can convert the unit of given physical quantity from one system into another system. Principle of homogeneity can be applied here. It can be written as N1 is equals to N2 of M2 power X, L2 power Y, T2 power Z, where M1 and M1, L1 and T1 are representing the units of mass, length, time in SI system, kilogram, meter and second. M2, L2, T2 are representing the units of mass, length and time in CGS system as a grams, centimeter and seconds. So N1 and N2 are the related to the units of given physical quantity in SI system and CGS system. So M1, L1, T1 representing kg, meter, second. M2, L2, T2 are representing gram, centimeter and second. So N1 is the unit of given physical quantity in the SI system and N2 is the unit of given physical quantity in CGS system. So using this formula we can convert the unit of given physical quantity from one system into another system. So standard principle of homogeneity here we use is N1 of M1 power X, L1 power Y, T1 power Z. This is Z students, this is Z equal to N2 in N2 of M2 power X, L2 power Y, T2 power Z. Now taking an example, how can we convert? So we are taking an example. So we are taking an example to convert the unit of force from SI system into CGS system. So we want to convert the unit of force from SI system into CGS, that is from newtons into dynes we want to convert. So 1 newton makes how many dynes? And for this one, first we want to write a dimension formula for force. So dimensional formula for force F is, we know the formula M into A. So M L power minus 2, that is M power 1, L power 1, T power minus 2. It is the dimensional formula of force. Now you can apply this one for to the principle of homogeneity. So principle of homogeneity we know students, N1 M1 power X, L1 power Y, T1 power Z is equals to N2 of M2 power X, L2 power Y, T2 power Z. So now we want to apply this. So suppose N1 value is a given 1 Newton and N2 calculate in the form of dynes. Students. So for this one we are making this one as a subject. So then N2 will become N1 of M1 by M2 whole power X, L1 by L2 whole power Y, T1 by T2 whole power Z. Students, just this is taken as a subject, and so this part will become a division. So on changing its position, on bringing this one to this side, it will become division. So now N2 is equals to, N1 is given as 1 Newton, and in the case of force, in the place of dimension m, power is there only m1 by m2 whole power 1. This is L1, L1 by L2 whole power 1. This means that here x is 1, y is 1 and z is minus 2 students from the dimensional formula of force. Now T1 by T2 whole power minus 2 z is. So from the dimensional formula of force we can write like this. So now, but in the beginning of this topic we said M1, L1, T1 representing kg meter second. M2, L2, T2 representing gram centimeter second. Now substitute this in the place of this one, students. N2 is equals to 1 into, so M1 means you can write kg and this is gram whole power 1, meter by centimeter whole power 1, second by second whole power minus 2. So M1, L1, T1 are representing the units of mass, length, time in SI system as kg meter second. L2, M2, L2, T2 are representing the units of mass, length, time in CGS system. That is why in the place of M1, M2, kg and gram, L1, L2 meter and centimeter, T1, T2 second, they are substituted, and x value, y value, z values are taken from the dimensional formula of force in the form of exponents, students. Now so we are going to convert SI unit of force into CGS. That is 1 Newton makes how many? 1 Newton makes how many dynes, students? So this implies N2 is equals to 1 of kg means you can write 1000 grams by gram whole power 1 by gram get cancelled, 100 centimeters by centimeter whole power 1, and second will be cancelled whole power minus 2, because these kilogram is changed into gram and meter is changed into centimeter, means that we are changing into same system, the units are changed into same system. So this implies N2 is equals to, it is a 10 cubed, whole power means 10, that is it is a 10 square, and minus 1 whole power minus 2 means 1, so which is 10 power 5. So 1 Newton is equals to, N2 is taken in the form of dynes, students. That is why 1 Newton is given, which is equal to 10 power 5 dynes. 10 power 5 dynes. So using principle of homogeneity, we can convert the unit of the given physical quantity from one system into another system. Now we are taking one more example. So practicing with many examples, you can understand this application or second use of dimensional formula or dimensional analysis, students. Suppose we are going to convert the unit of work. So unit of work from SI system into CGS system. From SI system into CGS. But SI unit of work is joule and CGS unit of work is Erg. Erg is the CGS unit of work, joule is the SI unit of work. So for this one, first we want to write a dimensional formula of work. So dimensional formula of work can be calculated, can be found by the formula of force F into S. So force dimensional formula m power n, L power 1, T power minus 2. And the dimensional formula of distance S or displacement is L power. So m power 1, L square, T power minus 2. This is the dimensional formula. And here m power x means x value is 1, L power y means y value is 2, and z power t power z means z value is minus 2, students. So now So consider N1 is given as a joule, 1 joule. We want to convert joule into ergs. So we want to calculate. So erg. So how many 1 joule can make how many ergs? So for this one we are following the formula. We know that N1 of M1 power X, L1 power Y, T1 power Z is equals to N2 of M2 power X, L2 power Y, T2 power Z. So this implies N2 is equals to M1 by M2 whole power X, L1 by L2 whole power Y, T1 by T2 whole power Z. So now N2, this is N1 students, here N1 is there. So N1 of, it is N2 is equals to N1 of students. So N2 is equals to N1 of, so this is X value M1 by M2 whole power and L1 by L2, Ly value is 2 students and T1 by T2, this is minus 2, and this is taken from principle of homogeneity. So let M1, L1, T1 representing kg meter second. M2, L2, T2 are representing gram, centimeter and second. So let M1, L1, T1 are representing the units of mass, length and time in SI system as kg meter second. Let M2, L2 and T2 are representing the units of mass, length, time in CGS system as a gram, centimeter and seconds. Now substitute them in this formula, students. So N2 is given as a 1 joule. We want to convert into years. So 1 of, it is kg. Kg means you can write directly 1000 grams. 1000 grams by gram. But initially we want to write kg by gram. Here also meter by centimeter. That is directly we are writing 100 centimeter by centimeter. It is whole power 1 whole square. Second, T1 is a second and this is second whole power minus 2. Gram, gram, centimeter, centimeter. So N2 is equals to, it can be written as 10 cubed students. 100 whole square means 10 power 4 and this is 1 power whole power minus 2, that is 10 power 7. 10 power 7. So Newton is N2 is taken as in the form of X. That is why 1 joule is equals to 10 power 7 years. 10 power 7 years. So like that we can calculate, students. That's all. Application of dimensional formula is a part 2. One more application is there that will be discussed in the coming video. Thank you.